In this video, we'll take a look at whole number division with partial quotients in a stacking method. This standard calls for students to extend their work of dividing a multi-digit whole number by a one-digit divisor to dividing by a two-digit divisor. The focus of this standard is to build a conceptual understanding of division with larger numbers. Although the traditional algorithm may be introduced, students aren't expected to master this algorithm until middle school. Let's take a look at how we can use partial quotients in a stacking method to divide 5,563 by 72. To begin with, we will estimate the quotient. This will help us because when we have our actual answer, we can compare our actual answer to our estimate to help determine if our answer is reasonable. When I look at 5,563 divided by 72, in order to estimate, I want to use some friendly numbers, and I'm going to need to rely on my basic math facts to help me with that, my multiplication facts. So when I look at 5,563, I'm thinking if I round that to 5,600, which it is close to, I can then round 72 to 70, and I can then use my multiplication fact of 7 times 8 gives me 56 to help me estimate the quotient. So now I can look at 5,600 divided by 70, and I can think, well, I know that 70 times 80 is what would give me 5,600. So this can let me know that my estimated quotient is 80. So again, when I solve, I would expect that the answer will be somewhere around 80. So let's go ahead and get started with using the stacking method to solve. First thing I'm going to do is write our dividend, 5,563. And then I'll show that that's going to be divided by 72. When you're using the stacking method, you're going to want to make sure on your paper that you have quite a bit of room above and below where you set up your division to be able to write, because you are going to stack your partial quotients on top, and then you're going to show your subtraction down below. It is a little different than the area model. So now what we're going to do, we still rely on partial quotients to help us divide, and we want to use friendly numbers for that. So I'm first going to think, well, 72 times 10, that would give me 720, which I can subtract from 5,563, but let's see if we might be able to get something even a little bit closer to start with as our first partial quotient. So if we tried 72 times 100, so if I tried 100 as my first partial quotient, that would give me 7,200, and I know that's too much because that's more than our dividend of 5,563. So maybe I'll try 72 times 50. And I'm going to try 50 because I already know that 72 times 100 is 7,200. And if I multiply 72 by half as much, so I'm going to multiply by half of 100, which is 50, then my product is going to be half of what the product was when I multiplied by 100. So 72 times 50, the product is going to be half of 72 times 100. That means 72 times 50 is 3,600. And if thinking about it that way isn't something that works for you, you could always come over to the side and set up an area model and multiply 72 times 50 or 72 times whatever partial quotient you wanted to try. I'm going to go ahead and use 50 as the first partial quotient. So I'm going to record that above here. That's my first quotient that I'm going to be stacking. And now I know 50 times 72 is 3,600. So I will go ahead and subtract that from our dividend. And I will see that I have 1,963 left. Well, I know that 72 times 50 would be too large. So let's try maybe 72. I know 72 times 10 was 720, which I could do, but let's see what 72 times 20 would be. Now, a couple of ways we could figure out 72 times 20. We could come up here and we could double 720 because 72 times 20 would be twice as much as that. Or we could just come to the side and set up an area model and work that out. Whichever works best for you is fine. So I'll use an area model for this one. So I'm going to do 72 times 20. So first I'll do 70 times 20, which would be 1,400. And then I will do 20 times 2, which is 40. So then I can see that 72 times 20 is 1,440. And that would work well for my next partial quotient. So I'm just going to record that here on my list. So that means my next partial quotient is going to be 20. So I will stack that above the 50. 20 times 72 was 1,440. So we'll go ahead and subtract that. And now I'm left with 523. Now, one thing I want to point out before we continue to divide is notice I am keeping this list of all of the multiplication for my partial quotients because it's always helpful to look back and use that to help inform future partial quotients. And I'm going to show you an example of that. I now have 523 left to divide by 72. I recognize that 72 times 10 would be too much. And so I could start to work out 72 times lots of single digit numbers, or I could use my list to help me. If I look here, I see that previously I tried 72 times 50, and that gave me 3,600. Well, I'm thinking that if I try 72 times 5, I know 5 is 10 times less than 50. So 72 times 5 is going to be 10 times less than 3,600. It's going to be 360. And I can see that I can subtract 360 from 523. So that means I'm going to use 5 as my next partial quotient. So I will stack 5 above the 50 and 20. 5 times 72 is 360. So I'll go ahead and subtract. And I can see that I have 163 left. Now, similar to my thinking before, I think my next partial quotient could be 2, because 72 times 2 is going to give me 10 times less than 72 times 20. And 72 times 20 was 1,440. And I know 10 times less than that is 144. So 72 times 2 is 144, meaning 2 can be my next partial quotient. So I'll stack that above all of the rest of them. 2 times 72 is 144. And I will go ahead and subtract. 13 minus 4 is 9, and 5 minus 4 is 1, and I have 19. Now this amount remaining here is smaller than my divisor, and so that lets me know that I am finished and that is my remainder. So my next step in the stacking method, it's very similar to the area model, is I need to look back at all of these partial quotients and I need to add them together to determine the total quotient. Some of you may be able to do that mentally with just having them stacked up like they are. Some of you may find it easier to write them over to the side and add them. Whatever works best for you is fine. But I can see that 50 plus 20 is 70, plus 5 more would be 75, plus 2 more would be 77. So I know that I have 77, and I can't forget about my remainder. So 77, remainder 19. So again, this lets me know that 5,563 divided by 72 is 77, remainder 19. When I compare that to our estimated answer that we did at the beginning, we thought our answer would be around 80, and 77 is very close to 80, and this lets me know that this answer is reasonable. And so that's how we can use the stacking method to solve multi-digit division problems.